everyone, we are from Group H and our topic is the philosophy of climate science and policy making. The philosophy of climate science goes beyond data. It explores how we study climate change, the assumptions we make and what they mean for the world. It blends science, ethics and philosophy to ask how much can we trust climate models? What do we do when science gives us probabilities, not certainties? Policy adds another layer, and it is not just science. It is a moral challenge. Who should act? Who bears the cost? How do we balance economic growth with environmental survival? Not just for today, but for future generations. Philosophy helps guide informed, fair, and responsible decisions in a changing world.
Climate models come in many forms, each representing components of the climate system, like the atmosphere, oceans, and land surface. According to Harvey et al. 1997, the main distinction between simple and complex models lies in their spatial dimensions, ranging from one-dimensional, 1D, to three-dimensional, 3D. Simple 1D models are easier to analyze and useful for sensitivity studies, while complex 3D models can capture detailed interactions across the globe. However, both rely on empirical parameterizations, for example, heat transport. In complex models, vertical heat movement is partially resolved, whereas in simple models, it's entirely parameterized. Finally, a key qualitative difference is predictability. Simple models cannot simulate unexpected climate events, like abrupt changes in ocean circulation. In contrast, complex models like AOGCMs can, though predicting their timing and specifics remains uncertain.
Climate models face two critical challenges: parameterization and validation. When representing complex physical processes, modelers in general must choose between good empiricism, which means that they have to use observations to derive parameters that remain fixed during testing, and also bad empiricism, which means that they tune the parameters to match current observations. So this type of empiricism will undermine predictive confidence. So the philosophical question remains: can models ever eliminate tuning completely? For validation, scientists test models against historical climate records. While Karl Popper's falsification principles suggest that models are strengthened when they withstand testing, complex models with multiple tuned parameters may achieve accuracy through compensating errors rather than accurate representation of climate physics. This tension between complexity, tuning, and validation creates fundamental uncertainty in climate predictions that scientists continue to address.
Now we are talking about uncertainty assessment and communication. Climate science has uncertainty, and that's normal. It's because the climate system is very complex, and our data and models are not perfect. Also, natural systems change, and we don't know exactly what humans will do in the future. Scientists use different methods, like statistics and running model many times, to figure out the possible range of what might happen. Simpler models might show a clearer range, while complex models show a wide one. Talking about this uncertainty is important but tricky. We need to be clear and honest without being confusing. Good communication helps build trust and supports good decisions. Understanding uncertainty helps us think about how to act wisely, even when we don't know everything for sure.
So in conclusion, basically the philosophy of climate science reveals that climate models, whether simple or complex, are built on assumptions and inherently involve uncertainty. While simple models offer clarity and ease of analysis, complex models provide greater detail but introduce more variables and broader uncertainty. Both rely on empirical parameterizations, raising epistemological concern about reliability and the objectivity of tuning. Instead of discarding models that don't align with observations, scientists often refine them, challenging Popper's principle of falsification. Communicating uncertainty effectively is crucial for policy use, but scientific knowledge alone cannot guide action. Ethical reasoning is essential to address fairness, responsibility, and the protection of future generations. By integrating philosophy with science, we support more informed, transparent, and morally grounded climate policies. So that's the end of our presentation. Thank you so much for listening.